Okay, yeah, I guess everyone knows what OsmoBTS is about. It's a BTS side APIS implementation that originally Jolly started in an attempt to make a BTS out of 2 OsmoCom-BB phones with some special software. Around the same time or slightly later, we also had the need, we as in Sysmocom, the company, to have a BTS side implementation because we were building a product with GSM hardware and layer 1 that needs some kind of APIS interface on top. So I think Jolly will not recognize too many parts anymore these days. Is that true?
Again?
You will not recognize many of the parts of the code anymore based on your original code these days.
I'm not sure. I've read the code and it's pretty much more. But the basics like the OML, RSL and stuff is quite similar.
Okay.
And the LabD thing, but of course it's now more complex.
You have to translate it in Erlang to make it unreadable.
Yeah, so it has evolved quite a bit in that process. One of the things that I tried to reflect from the very beginning is to have a different hardware or different layer 1 devices that could be connected to it. One of it is the OsmoBTS layer 1. Another one that we had in mind was some way of interoperate with OpenBTS. I'll talk more about that later. And of course the original one that Jolly started with this idea together with Sylvain to create a BTS out of 2 mobile phones. That project of course still is around, and it should also be possible to do that with OsmoBTS. So the common code like setting up OML, RSL, handling all the various messages on the APIS interface, managing OML state transitions and all that is common, or dealing with RTP streams for the actual media that gets transmitted. That's all common code, and then there is BTS specific code where right now really only the OsmoBTS backend is complete, and the other OsmoCom-BB of course is in a non-functional state because many other parts are not there yet on the phone and so on. Now, recently what has happened is that Thomas from Virginia Tech has I started some time ago to do OpenBTS, OsmoBTS integration, where the idea would be to use the OpenBTS transceiver and the layer 1 forward error correction L1 FEC class of OpenBTS, and then where it goes into the SAPI max and towards the higher layers in normal OpenBTS, to attach a different class at that point and then redirect the stuff into OsmoBTS so we can have an APIS interface on top of OpenBTS code. I brought that to some point but not to completion, and Thomas has been picking up on that and improved it and completed up to a point where it seems to be working for him and not in all cases and unstable here and there. But that's sort of the status. The way he implemented it is indeed quite a bit different than I would have foreseen it, because actually what he's doing, he's using the OsmoBTS layer 1 interface, and he replicates the same primitives and the same API that the Sysmocom layer 1 has, so OsmoBTS can run on top of it. That's not really how it was intended, because the idea was to have different L1s and each has their own interface and so on and so on, and of course it can be modified. It's not like the code is fixed and you have to work around the existing code by making OpenBTS appear like a different layer 1 that it isn't. So it's not clear yet how this will proceed. I'm not finished with the review. I'm happy that it is working and it is sort of complete, but whether this particular L1 interface will be that way, I'm not sure. Okay, that's it from OsmoBTS. I don't want to go into all kinds of details about the implementation. I'm not sure who would be interested in that. So I'll probably just leave it at that and leave it open for question and discussion, because I've been talking all morning. I don't want to talk all afternoon. Must be boring.
So the question is, what ABIS version is between OsmoBTS and OpenBSC?
It looks exactly like an IP access nano BTS.
Okay, so it's the access version.
Yeah, so in OpenBSC you don't even mention that it is a different BTS model. You just say it's an IP access BTS, and it will work.
Okay.
The point here is why invent yet another dialect of ABIS?
Yeah, but you have several other versions, so yeah. You have for Nokia and...
Yes, but none of them use IP as a transport medium.
Okay.
So well, yes, there's HSL. HSL BTS support in OpenBSC also, I mean HSL also uses IP as a transport layer, but HSL is, you know, I don't know, it looks like a really poor hack in terms of the completeness of the ABIS interface. So the IP access ABIS dialect is, it seems actually very well done, and there's no point in, no point in making something completely different yet again. So we just implement it the same way and are compatible on
Don't you think IP access will come after you for copying their precious messages?
Well, I think they can try, but I mean, it's like Microsoft coming after Samba. I mean, you look at the protocol traces and you re-implement something that's interoperable to the same protocol. Actually, even it's something that even the copyright wants to encourage. The European Union Copyright Directive, you would even be permitted to do reverse engineering on the proprietary implementation in order to create interoperable code. So I think, yes, somebody may try, but I don't think there really is much legally here, because it's a communication protocol. 90% of it is in IETF specs anyway. They have added a couple of custom messages, and we create something that interoperates with that protocol. So I don't see why that would be a problem. I mean, the internal details of our implementation may be completely different. It's an external interface, and I don't think. I mean, it may be that at some point we need to deviate from that. So in OpenBSC we should probably introduce a different, just an alias right now.
What different?
An alias.
Alias.
Yeah. So you don't say IP access if it's not an IP access BTS.
Right.
I mean, one difference is now in the hardware, because the OsmoBTS, at least if you use the OsmoBTS, it's a quad band design, so you have one BTS and you can software reconfigure it to any of the 4 bands. And of course, no other BTS that I have seen has this capability. So there is in ABIS, I mean, sort of, also OpenBSC has the concept that you specify a band for each BTS, which sort of doesn't make sense for this BTS type, because there is no band. In a sense that you can set any RFGN on any band. The band is not an inherent property of the BTS, because it's a quad band BTS.
Yeah, but you have...
Yes, yeah, you still need to specify that, but I'm just saying there are some things that probably may not be exactly the same. But otherwise, yeah.
Okay.
What's currently not implemented yet in OsmoBTS is handover, but it's, I mean, Thomas actually said it's something important that he needs, and I gave him some hints how to do it, so I would expect that to be implemented soon. It's not a lot of work. I mean, it's really just activating the right SAFI, layer 1 SAFI on the TCH, because all the logic for handover is done in the BSC. So the BTS just needs to activate a channel at the right point in time and activate the proper layer 1 process on it at the right point in time. So.
Okay, so am I correct that right now the most complete version of OsmoBTS works with SysMoBTS?
Yes.
Okay.
Yeah.
And
that's
other
all.
ones are like nowhere close to that.
Yes, but I don't think it's a lot of it's a lot of effort to bring it closer,
Yeah, okay.
because most of the code is shared anyway, and especially with Thomas' approach on replicating the layer 1 interface.
I think it's not Thomas. Yes, yeah, Thomas, but different Thomas.
Yeah,
Thomas
So it was Cooper.
No, Thomas. So
No, Thomas. I think Thomas Zhu is just kind of liaison, and the actual implementer is Thomas Cooper. And Thomas Cooper is the one who wrote the mail to the mailing list.
oh, he is.
Yes.
Yes.
Right.
Yeah, it's Thomas Cooper.
Yeah. He's a student in Virginia Tech, and he's in a close contact with Thomas Zhu, but he's not Thomas Zhu. Thomas Cooper.
Ah, so now you tell that while we are on video.
Finally got you.
No, I just read until Thomas. Oh.
So actually, I have a quick question. So far, there haven't been any transceiver modifications to BTS do this. This is basically this is all modifications in the layer, what used to be the layer 1, layer 2 interface. Is that correct?
Yes.
So we can run it on any transceiver at this
Yes.
point.
Yes. There's no change to that at all. So it's really, there's a new SAPMAX class that exposes the same, like it's derived from the same root class, and it will then basically, everything that's done in all the different threads will get multiplexed into one message queue, or actually 2 or 3 message queues, depending on what type of message it is. And then those message queues.
It's resetting. It's not my fault.
My lunch is settling.
Sorry? Yeah, it will settle. I know the device.
My lunch is settling, that's all.
Ah, yes. Yeah.
It's
Since
settled.
now we know you're a cyborg. So yes, no changes to transceiver, and I don't really think there would be any changes required ever.
If he's going to support handover, he's going to need to make some changes. That's it. He won't change. He'll need to make changes to transceiver and the transceiver interface to support handover.
Because the transceiver doesn't ratch, it's no way to tell it to do ratch detection, or no? But it's outside of the transceiver anyway.
The ratch detection is inside the transceiver, and normally it only does ratch detection. Ratch detection is the most computationally expensive thing the transceiver does. So it only does it on the ratch. If you want to support handover, you've got to tell it to look for access bursts in other places, and you don't want it to do that all the time.
Yes, no, I know it needs to be explicitly told to do so, but I thought maybe it was just not implemented or something like that, but I mean, so there may be like one more instruction on the transceiver interface to enable or disable that ratch detection on a TCH.
Yeah, I think so.
That's all.
Yeah, you'll need code to tell it to look for the ratch burst, and code to tell it to stop looking for the ratch
Yeah.
burst.
But the telling and the stopping, I mean, that's something that the OsmoBTS does anyway, even for the OsmoBTS L1. So that already exists. It's just a matter of
Getting the command
defining how to send that to the transceiver, and also defining an acknowledgement or something in response or whatever, and actually implementing, of course, the action of doing the ratch detection inside the transceiver. But I think it's a very small chain, and I guess you will have already some code in the private version, maybe. I mean, not some message in the private version of OpenBTS that does that, so it might make sense to publicize that part.
You might as well tell them what the interface is so that it's the same.
Yeah, exactly.
So, if I understand correctly, actually, there is a command which tells which time slot runs which detector, reg or reg or TC.
You have to add a command to the transceiver to tell the transceiver to look for access bursts on a particular physical channel. And you have to do this while the handover is pending.
Yeah, but on
But
what
once you've
transceiver?
seen and processed the batch burst, you want to turn that off because that is a computation
Yes,
demanding
yes.
task.
Okay,
You
so,
want to stop
but-
it as soon
yeah.
as you can.
Right, but I mean, what I tell is that right now when transceiver starts, OpenBTS actually instructs transceiver what detection to run on which time slot.
Yes.
So we basically can use the same command. We can just switch from T channel to reg with the same command or not.
You're gonna have to add another command. I'm not telling you this hypothetically. We have handover working in the lab right now.
Yeah, I know.
You need to add the command to do it to
Okay.
make it work right.
Okay. Yeah. Well, that's something Dmitry is going to do in a month probably. So.
Well, as I said, it seems that Thomas 1 or Thomas 2 are
Thomas A, Thomas B.
Oh, the other thing I can tell you is to actually add handover to OpenBTS.
So what?
To actually add handover to OpenBTS is a lot more than modifying the transceiver.
Yes, sure. Yeah.
It's a lot of, there's a lot of moving parts to handle.
yes. That's if you run it in the SIP OpenBTS configuration.
Right.
Yeah.
Right.
But if you, of course, if you run with OsmoBTS, then the VSC
It's
takes
already
care
there.
of all these parts because it already works with other BTS.
Yeah, I just telling that we'll be do this anyway. So yeah, for OsmoBTS.
Yeah, so we might as well publish the interface so that everyone does it in a standard way.
Yeah, that would be perfect.
That may actually be, it's a different topic, but that may actually be a good idea for the entire transceiver interface. Not just, not the implementation, but if there is some kind of
The
new
rest of
command.
it's documented, there aren't a bunch of undocumented. I mean, the rest of it's there's a readme file in the transceiver directory.
Yes, I know that, no, but I don't know what kind of other modifications to the interface you may have made internally.
Right.
So that's what I'm saying, is whenever there is some internal,
Yeah,
since
we
it's
should-
just the interface, not the implementation, it may
Yeah.
be a good idea to keep things in sync.
No, you're right, it's probably a good idea.
To make sure that we don't
Yeah.
end up with incompatible.
Yeah, because there are a couple other mods that are also necessary to store GPRS.
Yeah, that's what we are looking as well.
So yeah, and I mean, I haven't seen the modifications, but I would have the feeling that the interface itself would not disclose too much about your.
I'm not worried, it's not, we will have this discussion tomorrow.
Yeah. Okay.
I'm
Sorry.
sure we'll have this discussion.
Yes. Okay. Sorry for. Okay. Yeah. Questions. Further questions.
Yeah, I just wonder how do they do 4-band BTS? Do they have 4-band bandpass filters and switch between them?
Sorry,
You.
four. Yes, it has four. And it has four receive stages, and it's basically, you can think of it like a quad band phone. It's just that you need to have receive and transmit active at the same time. But a quad band phone also has, if you look at the Osmocom BB phone, well, normally they're only dual band, but you have two receive paths, then you have two high band, low band, you have the band filters for each of the bands, and then you have one chip that can switch between them.
Yeah, okay, so you have four bandpass filters, okay?
Yeah.
Yeah, this makes sense. Because you can't do a BTS without a bandpass filter actually.
No. Of course, there are bandpass filters and LNAs and so on, but you have. The question is basically, I think it comes from a commercial point of view. It comes down to how many different configurations do you want to have in stock, and do you want to have to manage and keep spare parts and so on.
Right.
So if you put all four on one unit, then you don't have to deal with it, because we have lots of other hardware configurations, like this OCXO or not, the GPS sync or not. Right, then we have
Yeah, then multiplies.
yeah, exactly, with this faster or a slower speed DSP, or all these different things, and it explodes at some point. So you have to remove some of these
Yes.
PoE or not.
Can you provision schematics of the?
No.
No.
No. The hardware design is not done by us, it's done by a different company, and I mean, it had also always been from the beginning, maybe, at least I think we have been very clear that it's not an open hardware project.
No, but you can have equipment where you just publish a schematic, but you don't. They're PDF, so you can't just. They're not in a CAD format, so you can't really reproduce the board, and there is no PCB design or stuff like that. But just
because
schematics not.
Yeah,
no,
publishing schematics is not an open hardware actually.
Yeah. No, but still, no. There's no schematics. We are able to give you a JTAG and serial port of the DaVinci and GPIO information, and it's basically visible in the kernel source anyway. So how things are connected. That also, yeah. So at that level, that there will be access to the hardware. There is access to the hardware. Of course, everything on the Linux side is open source software, and free software as well. So. So I think right now it's a 3.2 kernel running on the DaVinci, and all the drivers that you need for interfacing with the DSP and so on is all in the source code. And
so it's DaVinci.
It's a DaVinci.
And it's single RFCM.
Yes.
Okay.
You can stack multiple units, and then you have multi.
And the documentation about the L1 interface, I mean, obviously the function names are going to be visible just because you have to combine them, but will the actual documentation?
No, the documentation is not released, however the original header files are released. So
you have to guess?
No, the header files have lots of comments in them. So,
okay.
You know, every value in an enum has a comment, and every data type has a comment, so I think it's pretty... and this together with the working BTS source code, I think it's. I mean, you can see Thomas has managed to implement the BTS side even without the header files. I mean, so wow, it's amazing. So I think it's okay at that level. I mean, pushing for anything more. I think I'm not sure whether it's really that important. And if you have questions about it, you can always mail me. Right? If there's any question on how to use it. The good part about, I mean, I don't want to sell you anything, but the good part about this L1 is that it's complete. I mean, in a sense that it supports even the most strangest AMR frames, like the RAD SCCH and all crappy kind of crappy things that exist. They're really all implemented there, and also all the GPRS and Edge MCS 1 to 9 is there. Just the higher level stuff is missing, but it's really complete. It has A51, A52, A53, all these things. That's also why we decided to go for that, since it's a complete layer 1, and we don't have to start from scratch with an open source version or something like that. And I think it's a good compromise in terms of time to availability and development costs and so on. Yeah, availability may be an interesting point since I'm at that. It was supposed to be, so the final, we have the final board, I can bring it tomorrow. It was supposed to be manufactured end of February. It was delayed to the end of March, and now it has been delayed into April. It seems that some of the parts have some problems in sourcing them. So the OSMO will be a less perfect OCXO, for example, in the first manufacturing. That's like April really. I'm very hopeful that they will finally be available.
In April they will be manufactured, or you already will have them?
Both.
Both.
Okay. And then there will be follow-up runs, of course, from that point.
So what is the price point for it? Or you can't tell right now?
No, we can talk about that, but I would not want to have that on the report.
Okay.
Because I mean, the pricing will be different for developers than for commercial deployments, and I don't want that to be disclosed. Technical questions.
So what
It has 12 watts power consumption. It's maybe an interesting factor.
What
maximum?
12 watt power consumption. So what is the output power?
Depending on the band, up to 26 dBm. Sometimes only 26. 200 to 300. And separate RX and TX output. Network listening, so there's another RX for downlink receive of other BTSs.
And is it turned on permanently, or
The
just?
receive, no.
And so, what is the reason to have the network listening? Just for startup to find a free RFCN, or?
Depends on your application. You can use it for that, or you can also use it for calibrating your oscillator in case you didn't want to spend the money on the OCXO, for example.
Yeah, but then you need it to run permanently, or almost permanently.
No. You don't.
Well, it depends. It depends. Huh?
So there is always an OXCO, but it may not be calibrated.
No. You can have it without OCXO. And it only has a VCT-CXO.
Yeah, but then you need to pretty often to recalibrate that.
Yeah, but not always.
Yeah, I mean, permanent.
So you can, if there's some unused time slots while you're idle, while the BTS is not fully loaded, then you can actually devote some processing power to that. And you can recalibrate. But also, if the VCT-CXO is if you have calibrated it once, and if you know how it will vary even with temperature variation and so on, I think it's quite accurate. And even the OCXO you need to calibrate from time to time. And so you need a MA to calibrate against some reference signals. It can either be a GSM signal or a GPS, 1 GPS pulse.
Yeah, so if you want to do this recalibration at runtime, then you have to have free slots when the other BTS has FCCH.
Not necessarily. You can actually find a frequency error from normal burst.
Yeah, if you close enough, then you can even from normal bursts you can get the frequency error, and even the Calypso does it.
Okay.
Is it passively cooled?
Sorry?
Is it passively cooled?
Yes. I mean, it depends on your environment temperature requirements, but yes, it's passively cooled. Yeah. It's a 12 watts power consumption maximum, and I mean, in there you have everything. You can, of course, since it has the DaVinci, you can run even OpenBSC on it or OsmoNIP on it, and then you have a device size like a Wi-Fi access point, and you have a complete autonomous GSM network that you can make internal calls and drop calls externally. So,
I wonder, is it certified by some European certification?
not yet, but we're working on that.
Okay, and for what profile?
Just for the Pico BTS.
Pico BTS.
Yeah. But, I mean, there is another version in the pipeline with an amplifier that will also be certified according to a different profile, but that's not at the moment. Does it run Windows? Why do you have to reboot it so often?
It's if you configure it or download the software, then it's, I don't think
It doesn't run Erlang, no? No runtime code.
Do you know of any professional equipment which actually has those features that you can, during running, reconfigure it, install new software without disruption of service?
I would expect on real world MSCs, yes.
On the MSC, okay, but not on the endpoints. Can OsmoBTS change the firmware during?
No, by the way, is
Yes,
the support
can.
for AMR
And it continues to run and accept calls?
in the OsmoBTS?
Function sorts.
The layer 1 has complete AMR capabilities in the, in the actual BTS code. I think we only support one fixed code mode, CMR, the multi-rate set. But it's intended to have the dynamic up and down switching as well. But there's one codec mode configuration or whatever multi-rate set. I don't remember the exact term, but one set of codec modes that is statically configured right now. But you get the SID frames and you get the starter mark when after DTX the conversation picks up again. So all the on the RTP side it really looks like a normal. Just like IP access also has the same. If you look at the RTP headers, you have all these indications like silence detection and the marker bit. When there is the onset frame on the radio layer, then that will be translated into a marker bit in the RTP frame. And from the layer 1 you already get all the different frames decoded, so it will tell you the CMC, the codec mode command, codec mode indication. It will tell you whether it's a onset or all the different AMR frames. So with each frame you get very detailed what exactly it is, and you can act on that.
So the layer 1 takes care of silence detection and stuff like that, or you must take? Oh, I guess you act from the incoming RTP streams.
Yes, there's no transcoding in the unit. It's just whatever RTP stream you get from the media gateway, it will just translate between the on-air format to the RTP format, but nothing regarding silence detection. Okay. Other questions?
Does it have, so what time synchronization options it could listen to the network, and does it have GPS?
So one PPS input, yes.
Sorry.
Okay. And the UART even, so you can, it's a UART plus one PPS on a board-to-board connector.
Okay, yes, and so you could have external GPS to connect to it. Okay.
Yes,
Yeah,
even we can put it in the case even, it's whatever you want, it can be external. Because external GPS then, well, you need normal GPS modules, of course, have just a serial port, not with the one PPS on any of the pins, so it would be possible to do that in the case itself. Then you have an SMA connector for your GPS antenna. That's it. Yeah. Anything else regarding OsmoBTS? Not really. Questions? Any more?
You mentioned broadband support. Do you have many pairs of filters in each one of the BTSs? Or do you have to hardware configure one BTS to one end?
No.
So each BTS can only by software configure to run on any other band?
Yes. You just set in the BSC what you want, and it will instruct the BTS to use the band accordingly. And also there are no blockers at the band. So you can even do railway GSM with the BTS, because if it goes, the RGSM ARFGAN are included. So this is another problem with lots of normal BTSs. You cannot configure them for railway GSM, which some people of course need if they are in the train business. Okay. And as I said, multiple TRXs, you can stack them. There's some RJ, either board to board for actually stacking the PCBs, or with some RJ45 cable from one unit to another for passing the timing information to make sure they're all synchronized. And then
Is the oscillator pluggable?
no. The OCXO is soldered, but well, actually, any specific question or any specific application? There is a right now I'm running one of the boards with one of these, just because, as I said, the OCXO has some sourcing issues. This is a 5-volt OCXO board that we now also have in the shop, and you can put a UFL connector on the board for injecting the oscillator. So yes, we could put a UFL to SMA pigtail, and then you can have an external clock input if you wanted that. And it doesn't have to be 26 megahertz.
Internally, it can scale the frequency.
Yeah. So. Okay.
So you could feed it directly from the NVGPS, the usual modules.
Yes, if you run it with a divider that will not cause that picture.
Yeah, sure.
So yes, you could do that, but if you want to do GPS, well, the board has a VCT6O that can be disciplined by 1 dBs, so why would you put it?
Why would you run
But yes, if you have a rubidium 10 megahertz reference, then you can use that if you want.
Just so that your power consumption is like triple that.
Yeah, or if you have an actual atomic clock, I don't know.
Active hydrogen laser the size of a washing machine.
It's not PoE, is it?
No, but well, no and yes. I mean, normally it's not PoE, but we can combine it with the PoE power supply in one case, so then it is PoE. It's yeah, but you need a high power PoE because I think 12 watts is slightly above there's two power levels in PoE, and I think it's slightly above what the lower one permits. So you need to have a proper, I mean, a switch that can supply the sufficient power.
So you haven't included the poor man's PoE jumpers that just short.
No, it's real AF or whatever.
No. PoE is 15 watt max.
Ah, okay,
The lowest,
that's fine. Then it's fine. Ah, yeah. It was the PoE to 5 volt extractors that had some different constraints. Yeah, but PoE is something.
What you said, it's 20 watts and
No, 12.
12 watts.
Yeah.
Missing that.
And that's maximum. I mean, normally it's much less, but it's really if you run lots of CPU intensive stuff on the ARM, then it goes to that point. Or maybe with GPRS. Okay. Okay, then we can stop the recording.